Alright, I'm going to talk to you about some of the vocabulary words that we have for this unit. We have a lot of vocabulary words, so really I'm just going to talk about the first 4 sections of vocabulary words that we have that you need to make sure that you understand, okay? The first word is acute angle. By definition, an acute angle is an angle that measures less than 90 degrees, and then here is a picture of an acute angle. Adjacent angles are angles that are in the same plane that have a common vertex and a common side. That sounds really fancy, but basically it's angles that are next to each other. But they have to have a common side. And what that means is, here is an angle right here, and here is an angle right here. Well, they're not really next to each other. They're not adjacent to each other. They may seem like they're near each other, but they're not adjacent because they don't have a common side. Now, if I fixed it so that, sorry, I was trying to move it, but it's not working. If they shared a common side, then they would be considered adjacent because they have to share a common side. Okay? An angle is a figure formed by 2 rays with a common endpoint called a vertex. And so what I want you to get about an angle, I know that you guys all know what angles are, but what I want you to get is how to name the angle. So we can name an angle 3 different ways. These are points on here that we're going to use to help us name the angle. I can call this angle ABC, I can call this angle CBA, or I can call it by its vertex. B is the vertex because that's where these 2 rays, that's the common vertex that they share. This is where they intersect. And so that vertex is another way that I could name this angle. You're better off using 3 points to name an angle just so that you're more specific, because sometimes there's going to be several angles that share the same vertex. For example, right here, this could be vertex X. Well, which angle is angle X? You don't know which one it is, so you would need to be specific by labeling points on the end of each of the lines so that you can name the angle more accurately. But you always want to put the vertex in the middle. Notice that I have B in the middle here. You can't, this is not angle BAC. A is not a vertex. Okay, so you want to always make sure your vertex is in the center. Complementary angles are 2 angles whose measures add to 90 degrees. So if I add 2 angles up, they are adjacent to each other. They have that common, they share that common ray. And their sum is 90 degrees, then they are complementary. Okay, so 2 angles together that equal 90 degrees. By definition, mathematically speaking, a line is a straight path that extends without end in opposite direction. That means they go on forever. But instead of actually drawing the line forever, we put little arrows on the end so that we illustrate that they go on forever. Lines need to have a name. You need to have a way to name the line, so we put the points on the end close to the arrows. Now this isn't where the line ends. It doesn't end at D, or E, but this is just a way that we can help name the lines. So we would call this line DE or line ED, and this is the way we write it geometrically. Okay, we put the little symbol, the line symbol up above it, and notice, I know it's hard to probably see, but it's got the little arrows there, okay? A line segment is a part of a line between 2 endpoints. You can think of it as a chunk of a line, and it's got the endpoints. That shows where it stops. Okay, endpoints mean they do not keep going. Yes, they are points, but more specifically, they're endpoints. There's nothing going past either of these points. So this is line segment HI or line segment IH. Again, notice how I've written it here, and that it has the line segment symbol up above it. There's no little arrows over there. You don't even have to put the, when you're writing it like this, you don't have to put the endpoints on it. This shows that it's line segment HI or line segment IH. An obtuse angle is an angle whose measure is greater than 90 degrees but less than 180 degrees. Parallel lines, they will never ever cross or touch. Perpendicular lines are lines that intersect at a 90-degree angle, and they don't just have to, and it doesn't just have to be lines. Same thing with parallel. You can have 2 line segments that are parallel, right? But speaking about perpendicular, these lines intersect at a 90-degree angle. Well, the lines, you could have a line segment right here, and then you could have a ray right here, and then they form a 90-degree angle. So it doesn't have to be just lines. It can be line segments, it can be rays, but it has to be at a 90-degree angle. Okay? A plane is a flat surface that extends forever, and we've talked about this in class, how it's very hard for you guys to see planes, because so we've been just kind of illustrating it with paper, and that we can fold paper and have different planes. Planes, you name a plane by picking 3 points that are on the plane, but they can't be on the same line, and the order of the letters do not matter. So this would be plane ACB, plane BCA, BAC, CAB, whatever. Just picking 3 points not on the same line. Point is an exact location in space, so that was just an example of point C. Ray is a part of a line that starts on one endpoint and extends forever in the other direction. Again, the G is not where it stops. This isn't an endpoint, it's simply a point. The F is an endpoint. And the way we write rays is we typically put whatever is ending on the same side of that ends, and then the arrow side has the side that goes on forever. So this is ray FG. That tells me F is where it starts and G is where it keeps going on forever. We wouldn't call this ray GF, because that would mean that, oops, I'm sorry. That would mean that the end point G is here and that this is F. If we wanted to call this ray GF, I'm sorry, I know that's really sloppy. Let me write this a better way. Okay, so that would be ray GF. But again, with rays, the order does matter because it doesn't work both ways, okay? Then we have a right angle, which we've talked about. A right angle is an angle that measures exactly 90 degrees, and that's what this little symbol here, it illustrates the right angle. Then we have skew lines. Skew lines are lines that lie on different planes. So this plane is different than this plane down here, and they will never cross or touch because they're on different planes. Straight angle is an angle that measures 180 degrees exactly. Supplementary angles are two angles whose measures have a sum of 180 degrees. So we talked about complementary angles having a sum of 90 degrees. Well, supplementary have a sum of 180 degrees. Vertex, it's on an angle or a polygon, and it's the point where the two sides meet. So that the arrow is pointing to the vertex there. And then we have vertical angles. Vertical angles are angles that are opposite of each other. Vertical angles have the same angle measure. So angle A is vertical of angle B. They have the same angle measure. They are not adjacent. Adjacent would be next to. If this was angle C and angle D, angles C and D are vertical of each other. Okay, the adjacent angles in this diagram would be A and C, A and D, B, C. Those are adjacent, but vertical means across from each other.